Okay, so before I start on lesson 34, I just wanted to go over the equilibrant because we didn't get to that in class. You had a question about it. So find the equilibrant and write it in polar form. You add these two vectors, negative 14 and 130 degrees, plus 7, negative 30 degrees. And I'm not going to go through how you find the resultant because you didn't say you needed help on that. So if we did all the things and did sine and cosine and all that, adding those two vectors together, getting them in rectangular form, adding the x's, adding the y's, you would get in vector form 15.06, negative 14.22. So that point is right here in the fourth quadrant. And then if you wrote it in polar form, you would get 20.71 for the length of the vector, and then negative 43.36 in the clockwise direction. So you would get that for your resultant, but you don't want the resultant, you want the equilibrant. I don't remember, I keep saying it wrong. So the equilibrant looks just like the resultant. So it's this same vector pointing in the same direction, but it has the same magnitude, but it's flipped around 180 degrees. So it's pointing in the opposite direction. So it's going that way. It's the same 20.71, and now the angle is different because you're in the second quadrant, and these are vertical angles, so this is 43.36 degrees right here. So this vector right here is the equilibrant. So all you have to do now is write that, and they want you to write it in polar form. If you were to write it in vector form like this, you would just change the signs on x and y because now you're in the second quadrant, so x is negative and y is positive. So it would be negative 15.06, positive 14.22 if you're going to write it in vector form. To write it in polar form, you're going to have to decide how you want to do it. Remember, there's about 1 million different ways. Actually, there's an infinite different number of ways you can write it. You could write it where you go clockwise 43.6 degrees, so that would be, the angle would be negative 43.36 degrees. And then instead of going this way, you would go the opposite way. So you would make it negative 20.71. So that's one way you could write it. Or you could go with your angle clockwise and go that way to get there. And to do that, you're going to have to do 180 minus 43.36 degrees. And when you do that, of course, you're going to go in that direction for your magnitude, and that'll be positive because you're in the second quadrant now. So it'd be 20.71, and then 180 minus 43.36 is going to be 136.64 degrees. So there are many ways you can write it, but the equilibrant, you just find the resultant. So you have to find the resultant first, and then to find the equilibrant, you just take that arrow and point it into the opposite direction. Point it into the opposite quadrant, the quadrant that is diagonal to the quadrant you're in for the resultant. And then you just write it in polar form if that's what they ask you to do. So I hope that makes more sense. And now we're going to move on to lesson 34. Summation notation. This is going to be quick and easy because there's not much to summation notation. It's a nice little notation and you can learn it quickly. So this thing that kind of looks like an E is the Greek letter sigma, and it means, in math, it means sum. So this is a notation, and you just learn what it means, and then you can use it. So what this means is that you are going to start at y equals 1, and then you're going to go incrementally, meaning you're going to go 1, 2, 3, 4, all the way up to 4. And you're going to do this function with each number and then you're going to sum them together, add them together. So the summation from y equals 1 to 4 of y squared is equal to, you start at 1, 1 squared, then you go to 2, 2 squared, then 3, 3 squared, and then finally 4 squared. So that's what this notation means. It means start at 1, start at y equals 1, plug that in for y, see what you get, 1 squared, then move up to the next increment, 2. Do it again. Add that to the first one. Then put a plus sign. Go to the next increment, 3. Do this function. Then go up to 4. Do that function. Then you stop, because that's where you're supposed to stop. So this summation from 1 to 4 of y squared is equal to 1 plus 4 plus 9 plus 16, which is equal to 14 plus 16, which is 30. So that's how summation notation works. Let's look at a couple more examples. All right, here's one that's a little more complicated. This says you go from j equals 0 up to 3, and you're going to sum this function, or this relation, 2 to the j over j plus 1. So you just start at 0. So at j equals 0, you rewrite this argument exactly the way it looks, except for wherever there's a j, you put a 0. So 2 to the 0 over 0 plus 1. So that's your first increment. Now you're going to go up to 1. 2 to the 1 over 1 plus 1. Then you're going to add the next thing. You're going to go up to 2. So now everywhere you see a j, you're going to put a 2. So 2 to the j over 2 plus 1, j plus 1. Then you're going to go up and you're going to make j 3. And that's the final one, because that's where you're supposed to stop. So 2 to the 3rd over, j is now 3, 3 plus 1. And now you're done. So you're going to go ahead and add all this up. So 2 to the 0 is 1. 0 plus 1 is 1. 2 to the 1 is 1. 2 to the 1 is 2. And then you've got 1 plus 1. And then 2 squared is 4. 2 plus 1 is 3. And then you've got 8 over 4. So when you add all this up, you're going to have 1 plus 1 plus 4/3 plus 2, which is going to give you 4 plus 4/3, which is going to be 12/3 plus 4/3 is 16/3. Okay, this one says as I goes from 1 to 5, sum together 3. Well, there is no I in the argument of this summation, so there's nowhere to plug in the value. This thing, every single increment, it's going to be 3, just plain old 3. So if you start at I equals 1, you're still going to go through all these increments of I, but it's just that every single time the thing is just going to be 3. So you're going to start at I equals 1, because that's what it tells you to do. Start here. And what does this equal when I equals 1? Well, it equals 3. It doesn't change at all. Then you go to the next increment, I equals 2. When I equals 2, that thing still equals 3. Then you move up to 3. When I equals 3, that equals 3, because I is not in it. When I is 4, still 3. And then finally, I is 5, you're done. That's your final 3. So that is just going to be 15. So when the letter that's right here does not occur in the expression there, you're basically just going through the increments and adding that number over and over again. And since we're going from 1 to 5, 1, 2, 3, 4, 5, that's 3 times 5, which is 15. Okay, so that's summation notation. Pretty straightforward. All right, now we're going to talk about decomposing functions. So we're just going to remember about function composition first. So if you have two functions, f of x equals 2x plus 3 and g of x equals 1 over x, then f circle g of x, the composition of f and g of x, is the same thing as saying f of g of x. So that just means take the function g and plug it into the function f. So f of g of x here, this is what f of x does. You take whatever you put into it, multiply by 2, and then add 3 to it. So we're plugging in g of x into the function f, so we will take 1 over x, which is what g of x is, plug it in there for x, and now we have 2 times 1 over x plus 3. So that's 2 over x plus 3. All right, so that's the composition of two functions. Now we're going to go ahead and look at how you would decompose a function into the two functions that make it up. So we've got f circle g of x is equal to the square root of x squared plus 1. And so what we want to do is find f of x, find out what that is, and g of x. So we want to take this composed function apart and see what its parts are. All right, and there are many, many ways to do this.
You'll find many ways to say I love you. You'll find many ways to understand what love is. Many ways, many ways, many ways to say I love you. As you grow, I trust that you are finding many more ways to show and tell people that you love them. Those are the most important things that you'll ever learn to do.
And somewhat less important, you'll find many ways to decompose functions. So the first thing you do is look at the function and say, what is that function doing? So this function, f of g of x, is taking a number, x, and then squaring it, and then adding 1 to it, and then taking that and taking the square root of it. So that gives you a hint about how one way you can decompose this function. You can make one of your functions take the number and square it and add 1 to it, and then the other function can take the square root of that. So for f of x, we could make that the square root of x, and then we could make g of x do the squaring and adding 1. So if g of x squares the number and adds 1 to it, and then f of x takes the square root, then you get what you're looking for. So f circle g of x is equal to f of g of x, which is f of that g of x is x squared plus 1. You plug that into the f function for x, and you get the square root of x squared plus 1. So there are many ways, and this is one of those ways, and this kind of problem is not cut and dried. It's trial and error. So you may find it immediately, or you may find a couple of functions and try it and it doesn't work. So this is kind of it's a problem that it's not just step by step, this is how you do it. It's just trying some things and seeing what works. So here's another one. It says find f where g of x equals x squared plus 1 and f circle g of x is equal to 1 over x squared plus 1. So for this one, they're telling you one of the functions and you've got to find the other one. So they give you g of x and you're supposed to find f of x so that f of g of x is equal to 1 over x squared plus 1. So g of x is x squared plus 1 already. So it looks like all we need to do is make f the function that takes whatever you put into it and take the reciprocal. It makes it 1 over whatever you put in. So f needs to take g of x and put it in the denominator. So f of x, whatever you put into the f function, needs to take that thing and make it 1 over x, or the reciprocal of x. That way, when you take f of g of x, that's f of whatever g is already x squared plus 1. So you're putting that into this function. And that means for x, you're going to put x squared plus 1. And that is what you were looking for.